All right, in this video, we're going to be looking at a couple things. The first thing we're going to do is we're going to look at how to solve a polynomial by factoring. There's basically three steps. The first step is we're going to get it in standard form, or we can say get it equal to 0. So standard form equal to 0. The second step is we're going to factor it. And the last step is we're going to set each factor equal to 0 and solve it. All right, so let's start with this first one. So this first one, the first step, get it equal to 0. So we see it's not equal to 0, so I'm going to subtract 42 from both sides. Now it's equal to 0. Now remember from yesterday in the previous video, we learned if the a value is 1, these are the easiest to factor. All we're looking for is what two numbers multiply together to be negative 42 that add together to be 1, because that's our middle term there, 1x. And so that would be negative 6 and 7. Let's try that. So negative 6 times 7, yep, that's negative 42. And negative 6 plus 7 is 1. So that's a factored form. So remember that this is the easiest ones. Okay, so now we got it factored. So now we're done with step 2. And now we're into step 3. Step 3 is we're going to set each factor equal to 0 and solve it. So we would have x minus 6, set that equal to 0. X plus 7, set that equal to 0. So when you solve it, I would add 6 to both sides for the first one. I would subtract 7 from both sides for the second one. So I would find our x-intercepts, that's what this represents. Our x-intercepts would be at 6 and negative 7. Remember, yesterday we started the video by looking at a graph and taking the x-intercepts and putting it in factored form. Now we're working our way backwards. So once we have it in factored form, we could find those x-intercepts by setting them equal to 0 and solving them. All right, so that was an easy one, but let's do one that's a little bit more complicated. Now, when we're doing this first step of getting it equal to 0, I highly recommend, in fact, don't even do it any other way. Make sure that you leave the x squared or keep the x squared positive. So even though you might think it'd be easiest to subtract 2x squared from both sides, that's going to make the rest of our problem harder. So let's make it easier for ourselves by leaving the x squared positive. And so I'm going to add 9x to both sides and subtract 5 from both sides to get it equal to 0. So remember, this is one of those situations where the a term is not 1. So this is where we have to factor it. We're going to multiply these two together. So we get negative 10x squared. And then we have the 9x. So trying to find two numbers that multiply together to be negative 10, that add together to be a positive 9. Now hopefully you come up with 10x and negative 1x, because 10x times negative 1 is negative 10x squared, and 10x plus negative 1 would be a positive 9. So remember, what we do is we rewrite. So I'm just going to do this so we have some separation here. We're going to rewrite the first term and the last term. In the middle, we'd write down our 10x minus x. So we replace 9x with 10x minus x. And now we're going to do this by grouping. So we are going to group together the first two terms and the last two terms. So in the first two terms, I see you can factor out a 2x, leaving us with x plus 5. Remember what we talked about yesterday. If there's a negative here, we need to repeat that negative down below. So I'm going to repeat that negative, so it's going to be a minus. And between x and 5, there's no GCF, so then we just put a 1 here. So negative divided by negative makes that a positive x. Negative 5 divided by negative 1 makes it a positive 5. So now what we have in parentheses is the same, x plus 5. What's outside of the parentheses, 2x minus 1, is our other factor. So we would have these equal to 0. So now we're going to set each of these factors equal to 0 and solve them. So when you go to solve these, we're going to go to space here. I would just subtract 5 from both sides, so I get negative 5. Now this one, I would add 1 to both sides and divide by 2. So if you need to do that in separate steps, you can, but otherwise I hope you can start to do this in your head to see that you would add 1 and divide by 2, so you get 1/2. So our two x-intercepts there would be at negative 5 and 1/2. So I'm going to help you start this one together, and then I want you to see if you can't finish it from there. So for this one, again, we'll get it equal to 0 first. Don't know why this isn't cooperating. Here we go. So we would subtract 3x from both sides and then subtract 2 from both sides. So I would get 2x squared minus 3x minus 2. Now it's equal to 0. So remember, we would circle these. And so I want you guys, I'll help you, I'll stop after this, but we have negative 4x squared and negative 3x. So we got the negative 4x squared from multiplying 2x squared times negative 2 is negative 4x squared. The negative 3x comes from the middle. So I want you guys to take it from here. So find two values that multiply together to be negative 4x squared, that add together to be negative 3x. And I'm just going to write this down. So you're going to figure out what goes in the middle here, and then I want you to take and do the rest of it, get it in factored form, and then set those factors equal to 0 and solve. So go ahead, pause the video, and hit play when you're ready to check to see if you've done it correctly. All right, let's see how you did. So did you come up with negative 4x and x? If not, make sure that you talk to me so I can help you individually and work with you on this, because it's really important to know how to factor. But if you came up with negative 4x and x, great job, because negative 4x times x is negative 4x squared. Negative 4x plus x, sure enough, is negative 3x. So write this in the middle here as minus 4x plus x. And now let's go to grouping here. So we're going to factor out, let's see, I see that we can factor out a 2x from that first set. That'll leave me with x minus 2. The next set, remember what's the sign there is plus, as a plus, so we're going to include the plus. There's no GCF, so we're going to write down 1. So we're left with x minus 2. So between the two sets, we have x minus 2 in common, so that's one of our factors. And then what's outside of there is a 2x plus 1. So we're going to set those equal to 0. And we would get, boy, I'm running out of space here, we would get x equaling positive 2 and a negative 1/2, because I would add 2 to both sides for the first set, and the last one I would subtract 1 and divide by 2, and I'd get negative 1/2. So that would be your answer, negative 1/2 and positive 2. All right. We're going to go on to the next thing now, which this is a little bit easier. I'm going to have you, for these, we want to figure out what is the positive and negative intervals. So before we do that, I want you to have some more practice with factoring. So notice how both of these, the a values are 1. So pause the video and get both of these in factored form, and then I'll show you what to do next. See how you did. So the first one, hopefully you recognize that the two values that multiply together to be negative 3, that add together to be negative 2, would be negative 3 and positive 1. And the other one, what two numbers multiply together to be negative 21, that add together to be negative 4, would be a positive 7 and a negative 3. Now, it does not matter what order you put those in, so you can put those in any order. All right, now we want to, I'm not going to graph these, but we want to figure out where are the positive and negative values. So here's a little trick, positive and negative interval. So here's a little trick for us. We're going to create a number line. And on the number line, I'm only going to graph where the x-intercepts would be. So we would have an x-intercept at negative 1 and at positive 3. Because remember, we would set each factor equal to 0 and solve it. So now what we're going to do is we're going to use a test point. And we're going to see what happens in each of these intervals. Because notice how we have an interval here, we have an interval here, we have an interval here between and outside of each of those x-intercepts. So we're just going to use a test point. Call that TP for test point, not toilet paper. So the first test point, I'm going to pick a number less than negative 1, like negative 2. When I put negative 2 in here, well, negative 2 minus 3, negative 2 minus 3 would be a negative number. I don't care about the value. Yes, it's negative 5, but it would be a negative number. And negative 2 plus 1, negative 2 plus 1 would also be negative. So I'm putting negative 2 in each of those spots. And that would result in a negative answer in the first set and a negative answer in the second set. So and then we would have a negative number times a negative number, which would be positive. So between negative infinity to negative 1, it's going to be positive. Now what's going to happen here? Between negative 1 and 3, just pick another test point. We'll use 0. When I put 0 in for x, we get 0 minus 3, and 0 minus 3, that would be a negative answer. Again, we're not concerned with the actual value. We just want to record if it's positive or negative. When we put 0 in the second set, 0 plus 1 is 1, so that would be positive. And a negative times a positive would end up being a negative value. And now let's pick another test point bigger than 3. So that's in that next segment. So if I pick, let's say 4, any number bigger than 3 would work though. And if I put 4 in there for x, 4 minus 3 is, oops, I said we're not using values. 4 minus 3 is 1, so that would be positive. And if I put 4 in the second set, 4 plus 1 would be 5, that's also positive. A positive times a positive will be a positive answer. So now we're trying to look to see where's the graph positive and where's the graph, for what intervals is the graph positive and what intervals is the graph negative. So it's positive on the interval from negative infinity to negative 1. And it's also positive from 3 to infinity. And it's negative on the interval in the middle from negative 1 to 3. We use parentheses there because at 1 and at 3, it's not positive or negative. It's just 0 at those places. So don't use brackets here. We would just use parentheses, but these are the intervals where the graph would be positive or negative. So let's look at this other one that we already factored. And so again, we're going to just set up a number line. And we'll use our zeros. So the zeros, if I set x plus 7 equal to 0, we would get negative 7 and positive 3. So again, what I just did. So I did that in my head to be able to get those zeros. So again, we would have these 3 intervals. We want to figure out where in those intervals is the graph positive or negative. So again, one of the methods that we can use for that is using test points. So let's go through that process of trying different test points of negative 8. Again, a number smaller than negative 7, so negative 8. If I do that, I get negative 8 plus 7. Well, that's going to be a negative answer. Negative 8 minus 3, that's also negative, and a negative times a negative is positive. So before negative 7, the graph would be positive. Between negative 7 and 3, let's use a test point of 0. 0 plus 7, well, that's going to be positive. 0 minus 3 is negative, and a positive times a negative is a negative. And lastly, we can use a test point of 4. 4 plus 7, that would be a positive answer. 4 minus 3, that's also positive. A positive times a positive would be positive. So the intervals where the graph is positive is from negative infinity to negative 7. And also it's positive from 3 to infinity. And it's negative in the middle from negative 7 to 3. So without looking at a graph, that's how we can see where the graph is going to be positive or negative. The intervals goes back to what we did back in chapter 1. All right, this is the last key thing that we need to talk about. So remember, we have the factored form of a parabola. So here they give us the x-intercepts are at negative 2, negative 1, and it passes through the point negative 320. The first step is we're going to replace the x-intercepts with their values. We'll say we plug in x-intercepts. So if I plug in the x-intercepts, I'd have y equals a. And then it's going to be x minus negative 2, so that's x plus 2. Then it'll be x minus my other x-intercept, which would be negative 1. X minus negative 1 would be x plus 1. Okay, so that's my first step. Plug in the x-intercepts. Step 2, we're going to replace x and y with the other coordinate. We're going to do that to find a. So what do I mean by that? Well, they give us this other coordinate, negative 320. So we're going to put negative 3 in for every single x, and we're going to put 20 in for our y. So we would have the statement 20 equals a times negative 3 plus 2 times negative 3 plus 1. Now we're going to simplify the right side. Negative 3 plus 2, that's negative 1. Negative 3 plus 1, that's negative 2. And -1 times -2, that's a +2. So I'm just going to write it like this. So -1 times -2 is a +2, so it'd be 2a equals 20. So I divide both sides by 2, and I would get my a value as 10. So now we're going to write our equation with replacing a with 10. So it'd be y equals 10 times x plus 2 times x plus 1. All right, I want you guys to try this last one on your own. This last one, you're going to follow the same step where you're first going to plug in the x-intercept. Then after you plug in the x-intercept, replace x and y with the other given coordinate to find a, and then write your final equation in factored form. So go ahead and pause the video and hit play when you're ready to check your answer.